Thank you very much for having me. It's really amazing to be here in Atlanta. I was giving a similar talk like a week ago in Tampa, and it was a really smaller audience. Now this one is kind of more impressive now. So thank you very much, everybody, for coming here. And thank you for the introduction. My name is Vicente Romero. I've been in the compiler team in Oracle for 6 years now, and it's been a pretty impressive experience now. And but today we'll be talking, of course, today we'll be talking about Java, and we'll be talking about the features that are coming in Java. Some of them already in 10, some of them in 11, some of them in 12, and some of them that we are still thinking about what we will do now. And most of the talk is in the corners of why we take those features, why we think they are important for the community, and what's somehow you would probably see some of the procedure of the approach we get to select some features into the language now. So this is a note from Oracle lawyers. Don't make any decision based on what I'm saying. Don't buy long or short the stock or whatever. No. And this is so Java is now a millennial now. Java has been around for 20 plus years, and in that time, which has been impressive. No, I mean we started in 95, and it was oh my gosh, this language has everything. I was there when I was studying when Java started, and people were like going crazy with Java, no? And now it's a more mature language. There are other new things going around, but Java still is the language with the greater number of developers now, and that's for a reason. No? I mean, Java has invested a lot in trying to keep the users. No? Why? I mean, because we have make promises to our users, which is that we will make compatibility a core of the platform, no? And that and that has allowed our users to keep once they make an investment to continue growing and to keep that investment as something valuable to them, no? And that's something that, sometimes in the process of, when we are in meetings kind of discussing things that from the outside, and sometimes I see that when we hire people that has been working in other companies where probably they don't have the legacy that Java has, and sometimes they get like, why do we discuss this so much? Why don't we just hack and break the world, no? And it is like, okay, we have to evangelize you first, and the thing is that it takes sometimes years to make some changes that could be seen as simple, but there are so many pieces interacting between them, and so many different things that you can break, that it gives us a lot of constraints. No? So sometimes it is a bit of a very difficult, like playing Go. What you put here and not here is sometimes is like that. No? And as I was saying, our main concern is compatibility. And for example, when we introduced generics back in Java 5, there are libraries there that don't speak generics. but they can still interact with generic libraries or code. And the same happened with lambdas. When lambda were introduced, people had a lot of libraries depending on single method interfaces that worked with lambda without having to be recompiled. No? But still, programming languages need to evolve. I mean, programming languages exist in an ecosystem where they are praised, they are there are other animals trying to eat them, and they all evolve. I mean, the change of one make a change, provoke a change in the other. No, so Java has to change, but we want to do it without compromising our principles and without compromising our users. So, as I was saying, Java needs to continue evolving to adapt to new problems, adapt to new hardware, and meet ever-rising developer expectations. No? But at the same time, we just don't want to add features to the language just because. No? Because at some point, language can get full when at some point you can't add anything else. Remember that once you add something to the language, you can't remove it. It stays there forever. You can sometimes break some small things, but not big things, no? So that's why we think so much before doing additions to the language. And so, in particular, I'll be talking about two projects, Project Amber and Project Valhalla. I am mostly involved in Project Amber. Project Valhalla is more related to the hardware, more related to the VM, but still there are some changes to the language, of course. And in the case of Project Amber, it is more like to adapt to changing expectations on the users, reduce the ceremony. I mean, Java is a language that has been criticized for being too verbose. And Project Amber is trying to reduce that and modernize the language in the meantime. No? So, as I was saying, Java has been very criticized for being too verbose. And there are a lot of features that have been suggested to somehow reduce that verbosity. And we have to prioritize. No? We want to prioritize those features that, let's say, attack the most common problems. And not the decision is not being made based on, okay, it's just to reduce verbosity. No, we want to make semantics as the core, and the semantic change should make the verbosity reduce by itself. So within Project Amber, there are a number of projects. In the case of local variable type inference, is already released in 10. People were asking for this a lot. Programmers have seen this in Scala and C#, so they wanted something similar in Java. And there are other projects like rostering literals and expression switch that are already previewed in 12, and some other projects that are in the pipeline that I'll be talking later about them. So local variable type inference. The thing is, if we see this sample, this could be seen like very simple, no? Like, okay, I can see directly that this type is an URL or an URL connection or a reader. But the feature gets, shines when you have very complex expressions that you don't know exactly the type, and you don't want to figure out, okay, do I have to put a wildcard extending blah blah or a wildcard, you know? For example, when you have like streams that filters something with a lambda, that alters the type a lot. So you can just put a var. That simplifies your code a lot now. And some people have complained that probably readability can be affected with this feature, but our guideline for this is that if you have a very clear name for the variable, then the type is not that important. So even though the type is inferred, it doesn't mean that Java is dynamic as JavaScript. It's still a static type, and so the declarations that I shown in the former slide are equivalent. And it's just making the type inference in Java a little bit more powerful, kind of reusing the same gene that was already there for generic methods, lambdas, etc. Is there anybody using this feature, var, or you're using it? So probably you have been using it in other languages, not in Java, but still, no. So it is in Java. It is for local variables only, and so you can use it wherever a local variable is, no, within a method, resource, variable in a try resources, and implicit lambdas, for example. But there are places where you can't use it. No? For example, in method parameters, return types, and fields. And why not? Because they could alter the API of the class. They are reading into the class file. And if for some, let's say, change in the compiler, the type inferred is different, then you have a binary compatibility issue. So when we were working on all these Amber projects, because Amber is like an umbrella for a large number of projects, we're discussing, okay, but once we release something, that will be written in Stone. So we decided to, not because of Amber per se, but we decided that it was a good idea. Well, when I say we, it was they decided that it was a good idea that we should have a preview feature, something that was fully implemented, fully specified, but could change. So that will allow us to give something to the user that they can try and they can test and then give us feedback. And then we can probably make small changes to them before the final version. So we defined this preview thing. If you want to try a preview feature, you have to use these options, and it can be used for features like rostering literals, for example. So string literals require a lot of manual adaptation. When you get, for example, code from JSON, SQL, HTML, you have to escape a lot of characters. You have to take care that if the rostering is multi-line, you have to format the string very well. You can introduce bugs, etc. No? So this feature was very asked by Java users, and we decided to provide it. So, for example, this is the current state of the art. This is what a Java programmer has to do in order to get a multi-line string and insert it into a Java program. Sorry. So it is not only a lot of time that you spend doing this, but also you can introduce bugs, and those bugs usually are hard to find, no? And this is the code. I mean, this is how the code would be with rostering literals. As you can see, you can basically get the string from the language you are working or you are interacting with, and just put it in Java. If the string happens to have backticks, you can use double backticks. As I said, this is a preview. This can still change. But so far, I mean, with the current form, I think it's a pretty useful feature. Another bigger, I mean, with more entity feature is expression switches. So the thing that we observed is that a significant fraction of switch statements really want to be expressions. For example, you can have a common target. You assign to that target in all the arms. You break in all the arms. And this can be error prone. This can be, there is also a lot of boilerplates. And this is something that we wanted to improve. So this is the current form of a switch statement. No? So a very simple example, we have an enum that is the days of the week, and in every arm we are assigning a value to the same variable, and you have to put the break in all the arms. If you forget, then you have fall through, and you probably don't want that, and again those bugs are hard to find. So the common goal, as you can see, of all these projects is to reduce boilerplate and to reduce repetition, to actually reduce possible bugs. I mean, and this is what the same code could be with switch expressions. So it's a lot simpler, less repetition in the code. We are reusing the arrow syntax that we use for lambdas. And you don't even have to write return something. No, it's evident what the result of the arm would be. No? And we have also overload, let's say, the break. So if you use the arrow syntax, you don't have to use to do a return. You can just, I mean, the evaluation of that expression will be the result. But if you use the colon syntax, then you can use the break as another way of saying return this. No? But instead of returning from the method, you are just returning that as the value of the expression. Apart from these features, there is a number of features prepared to, or that we are working on. So records, pattern matching, language intrinsic for invoke dynamic and constant dynamic, targeted library intensification, seal types, and concise methods. I won't be talking about all of these. There are others that are not mentioned here, but I will be talking about some of them. So in the case of records, a lot of languages have records, and actually in the 90s, late 90s, it was like a religion that everything has to be an object, and object orientation was everything. But a lot of classes were just data holders, and we were using all the, I would say, all the power to represent something that was just a data holder. And the thing is that with applications like cloud, machine learning, whatever, we realize that we need something that is just efficient and just represents data as we want, no? And so what happens when you have this data holder that you want to represent, and you have to represent with object orientation, as in Java? Okay, you want to write this, but in order to have something that is consistent, you have to write all of this, no? If you forget to update the equals method, then you can have a bug. If you forget to update the hash code method, then you can have a bug. If you add a new field and then you don't update one of those methods, you can have a bug. So this is what we write, or what we can write with the current prototype. So you say record, the name of the record, the components, and if you don't have anything else to add, just a semicolon and that's it. No? So, and the compiler will generate all of the other things for you. So apart from the constructor, the hash code, the equals, it will generate accessors, it will generate other methods to interact with pattern matching that we will see later. So the compiler does a lot of magic for you, and at the same time you only have to strictly say, okay, the semantic of what I want is just a data holder, and that's it. And then the compiler will make sure that all the API that implies that will be generated correctly. So this is one of those features that seems trivial, that seems very simple, but the semantics is complex, and if you relax the semantics, I mean the semantics is not complex, but what I mean is that the semantics, if you make it very strict, then it won't work for a lot of people. If you make it very weak, it will work for most cases, but then you won't have the checkings that you can enforce with the semantics. So this work in progress, we are still making decisions here, but yeah, so far we like what we have, and of course we would like to have feedback from the developers. So pattern matching is another project we have been working on. It's a little bit more complex than the others, and pattern matching pattern matching has been present in a lot of functional languages, but it is strictly not a functional programming feature. And it combines three things: an applicability test, an extraction, and binding the properties to fresh locals for you to use. No? Doing this manually is often a source of problems. No? So this is the current state of the art. No? This is what we have to do in Java to simulate pattern matching. No? We have in each branch we have to check for the type of the object, and then we have to cast it to another object, or, I mean, depending on the case, extract the information and do something with it. This is a lot of repetition. There is usually a lot of copy and paste here, and that can lead to bugs. But this is, with the current proposal of pattern matching, what we can do. No? So we are here reusing the case. And so we are, as you can see, we are doing the three things in one go. So you have the test, you have the cast, and you can, and the value of the object gets bind to a fresh local, and you can do something with it. So, but if we combine pattern matching with switch expressions, then we have this even simpler code, and we have everything in one, and it's a lot simpler, a lot more readable, and easier to maintain in the future. So the state of the art so far for pattern matching is that we have the generalized case level 2. We have generalized the case level 2 patterns. We have added the type test pattern that you saw an example of before, and we are working on other interesting stuff like the deconstruction patterns. No? So deconstruction is the dual of construction. If you know how to construct an object, you know, or you should know how to extract the components from it and reuse them. And records are very efficient and very really made for that, no? Because the components of the record are part of the API of the record. So you know, you should know how to extract, and the compiler know how to extract that information from the record. So this is an example using the construction pattern. We have a record point with two components. We have a shape. Well, seal is another feature I'll be talking about later. And we have a record circle and record rectangle. And these are the components, and then in a switch you can use those records to actually extract the information from the records. And you can, for example, in the second case, you can say, okay, I will match only rectangles that are in the origin of coordinates. And I mean, you can build very complex patterns with that. And imagine writing this code with what we have now. No, it would be a lot of code. So another place where pattern matching shows the benefit is in API writing. Sometimes you write an API and you have a method that depends on another method, but that dependency is not. You can't write that in the API. There is no way to say, okay, whenever you use this method, before you have to use this one. You can't do that, but you can do that with a pattern. If in the past we would have had pattern matching, instead of having probably these two methods, is array and get component type, we would have had a pattern saying, okay, it is an array class, and if it is, give me the component type and I will do something with it, no? And you can make the mistake of calling get component type on something that is not an array if you have the pattern. So summing up, Project Amber contains a lot of projects. I've been talking about only a few of them, but we are working on some other interesting ones. And the idea is to make it easier to build and maintain reliable programs, to address some long-standing pain points, and to make that the semantics. We focus on the semantics in order to make the body take care of itself, no? And if you want to try it out, this is the repo. You can clone it, and some of the branches are datum for data classes. I'm personally working on that one. There is the patterns, and there is another project I haven't talked about, which is the intrinsics project. And there are some more that you will find at that repo, and that we are adding some more. Also, seal class. This is another project that is here, and we are right now defining it and making let's say the final decisions to start the Y open implementation. In the case of Project Valhalla, as I was saying, this is closer to the hardware, and the idea is to reboot the layout of data in memory. You will see some relation to records here. The problem has been or is being attacked from several places, I would say. But Project Valhalla is not only the representation in the language that is simplified. The representation in the memory is simplified in Project Valhalla. And the reason is that Java is a language that is very pointery, whenever you have an object, you have a header in that object, and then there are a lot of pointers everywhere, and whenever you have to compare two objects, okay, you make sure that the objects are identical if they point to the same I mean, is the reference point to the same object, but some objects doesn't need that. I mean, if you have to represent simple data, you don't need all of that checkings and pointers all around. So this is the layout we have now. So if we declare this, and then we declare an array of those points, this is what we have. So we have a header for the array, a header for every object. The array has pointers to every object, etc. No? And I don't think that somebody will log in and use the log of the point to do something with threads or something. I mean, we just want the data. So at the end, some people is forced to do this. I mean, to declare two different arrays of integers with both components of the points, and then you have to synchronize between them. So we are giving people the wrong abstraction level to solve the problem, and then people have to choose between abstraction or performance, no? And they have to pick one of them, and this is a bad election. And so this is the layout we want. We want this. We want to just say, okay, I have a value class, which is point. We have these two components, and if I represent an array of them, this is how I want the memory to be. And this is the goal of Project Valhalla, to get to a point where you can flatten an object in an array, or move or from an object to another object, and then have an efficient representation in memory.
So if you had point X and point Y, you wouldn't have two different headers?
Sorry?
If an array of points X and another array of points Y, they will still have their own header and everything, right?
In the array you have X and Y? Yes. Yes. But if you have an array of points, you will have only a header for the array. But you won't have a header for each point, because they will be flattened in the array. Of course, you lose for having that performance gain or that memory gain. You lose something. No? You lose the ability to check equality between two objects. And yeah, this is actually so. So the comparison of these value types is based on a state, not on. So you lose identity, you lose mutability, you lose polymorphism. So a value class can't extend another class. It can implement interfaces, but it can't extend another class. And but usually you don't need that if what you're representing is only data, and that's somehow the application for which this is oriented. So, but still, you can have fields, you can have methods, you can, as I was saying, you can implement interfaces. They can be generic. So the thing is that if once you combine generics with value classes, for example, I don't know if you remember, I mean, in 8, when we developed the string API, we had to have int string because string of integers was too slow for being performance. So, but when you combine value classes with generics, then you can write the class once and have the specialization. The compiler do the specialization. Sorry for you. So the workry codes like a class works like an int, no? So if you want to reason about what the value type can do, well, whatever the ints can do can be done by the value type. So that's the idea, no? And it can be seen as faster objects or user-defined primitives. And as I was saying, this is very important for applications in the machine learning and data intensive fields. No? So this seems simple, but when you start analyzing the interactions, yeah, I have questions, sorry.
Yeah, what would be the relationship between the record and the value type? Would both exist in the language? Or?
So you're asking what would be the relation between records and value types? Yeah, so that's something still to be defined. And actually, if you think of this, you could say, okay, why not doing value types first? And then once that is done, probably we don't need records, for example. Or we could have a stronger record when we have value types now. So these two things are moving together somehow, and we are still making decisions on that. But still, a record is a little bit different to a value type, I would say. But yeah, there are a lot of stuff in common. Yeah, that's an open concern also for us.
Does this bring us to the day where we can get rid of things like POJOs and DTOs? Is that what this leads to eventually? Like having to create these container classes with a bunch of getters and setters just to transport data back to it?
You mean with records, if they will somehow affect Java beans and this kind of stuff? Yeah, I mean, our hope is that people start using records instead of doing beans or pollos or something, because the idea is that the compiler will generate all the accessors for you. It will generate the hash code, everything automatically for you, and that you just need to focus on what the API of the record is, and not how you will implement whatever. And if you add a new field to the record, you don't have to go back and see, okay, how was the implementation of the equals, or how was the implementation of the hash code. If you don't like what the compiler gives you by default, you can still implement it by yourself. And that will be the version that the compiler will take as the good one. But the compiler should generate a good enough code for you. Yeah. Sorry?
There are also already third-party libraries which generate the setters, getters, constructors, and everything, like Lombok.
Yeah, they are. And of course, this work has taken inspiration on those libraries. But the thing is that the library can generate the code for you, but it can't read the code. So you still have to check that everything is correct, that everything is as you expect. And that's the thing, that once you declare the API, I mean, you're declaring the API of the record in the components, in the header of the record. So reading it is just a one line. I mean, if it is simple enough, no, it's only one line, and you won't spend more time on that, no. I mean, you still have to double check that what the IDE generated is correct, and that's something we want to save the developer. So, any other question?
Yes, for compatibility with older libraries that are not going to be recompiled, is there going to be some kind of construct that will transform embedded values into objects for compatibility? I assume that there shouldn't be an issue with compatibility. You mean in Valhalla, between value types and? So I've got new code that has value types that are embedded in my classes.
Yeah.
And I want to call something old, and I'm passing in a field that's a value. For that to work, I needed to somehow create an object instance that contains the value that is separate from where it's embedded.
Yeah. Well, right now there is an ongoing discussion in the Valhalla project, which is what will be the super type of value types. Will it be objects or no, or something different? And that somehow could affect how they will do what you're worried about. No? But yeah, I mean, this is something that is sorry, still under discussion, and I don't know exactly what the final solution would be. But this is one of the questions they are trying to figure out how to solve. Yeah. Any other question? Okay, so even though this could be seen as simple, it is not. No, I mean there is a lot of deep intrusion into the VM. I mean, new bytecodes, new semantics. There were ideas of reusing the existing bytecodes without creating new ones, and so this is a very active project right now, and a lot of decisions are being made right now. But there are visible benefits, no? Which that you, I mean, the programmer will be able to generate object graphs that are flatter, that they consume less memory and that are denser. So that would be good for the GC. Fewer indirections, fewer and smaller, well, fewer object headers, and faster objects in general. And as I was saying, you will need to do a specialization oriented to primitive types anymore, because the compiler should be able to generate that for you. And also you gain on abstraction. You have, I mean, the difference between primitive types and references gets less visible. And you have, you can write something once, you don't have to specialize more than once for every primitive type or for whatever primitive your application is more concerned about. And then users don't have to choose between performance and abstraction. So what's the status? Okay, there was a prototype a while ago, like a year ago, which was mostly a proof of concept. You couldn't do too much. Then early this year, they released LW1. They choose funny name sometimes. I mean, there is a reason for the name, but it's a little bit tricky. And so VM support for value types as a type of objects, as I was saying, initially they were thinking, okay, this will be two different words. I mean, that was the thinking. Everything bytecode, new bytecodes for value types, different from those for references, new signatures, and I think the two words are somehow now getting closer now. And so you can actually, let me show you where you can actually go and download the prototype and play with it, and you can actually see, I mean, there are a lot of tests already written, and you can browse through them and see how they use them and what you can really do with them now if you want to get prepared to once these arrive. The compiler in Bajara already is able to compile classes with value types, but if you want the VM to secure it, you have to use this special option. So in summary, as we have been talking about all through, we are planning to, I mean, we are doing things to evolve the Java language, but we want to do it in a compatible way, and we are very selective of what features we are adding to the language. And something that has been working very well for us is the evolution of the language, the VM, and the libraries together. That has been paying us a lot of dividends. And yeah, and we have a lot more features than ever, I think. I mean, with this new release cadence that is faster, we had a lot of new features to work on. Before it was like, okay, 3 years to work on Lambda, then 3 years to work on modules. But now, with this very quick cadence, we have a lot of small projects to work on. And well, that's it. That's my presentation. Thank you very much for.
Are the new generics going to continue to have type erasure?
Yes, yeah. That's something that I don't see there will be a change. It is a big compatibility issue, and we are still doing the erasure, and I don't see a change to that in the near future. Yeah, sorry, but it's true that you can do some inference with the signature attribute in the class file. No? You can infer, but you won't be able to recreate exactly what you had when you first compile the class. Yeah.
I was wondering, are you thinking of expressionizing additional constructs like try and catch or if maybe?
To what, sorry?
You said switch to possibly become an expression that can be assigned. Right?
Uh-huh.
I was thinking with try and catch that might also be helpful.
I think I heard proposals about that, but I don't think there is an active project for that right now. Yeah.
That would be a good one. Like you have a catch on this line instead of having like a block of catches and all that.
Well, I'm thinking, what if you need a piece of data and you have a try catch, you can basically the try block can return data, the catch or the finally can return data, and then assign it to a variable. If you need it, it's much more concise.
Easier to write functional code.
Sorry?
Makes functional code easier to write when you can handle exceptions as an expression.
Yeah. Yeah. Right now, I don't think there is any proposal, but I'm sure we will have. If we see that it's really important for developers, also feel free to write proposals to compiler dev, and there is another one I didn't speak about, which is concise methods that you can, for example, you have a method that is a one-liner. You can use the arrow syntax and write that line there. You don't have to open brackets, write your code, return. That line would be your expression. Uh-huh.
Will other languages on the JVM be able to use the value types on the VM level or bytecode level?
They could if they want, but I don't know if right now there is anyone doing that. Yeah, Valhalla is not my project. That's why I sometimes say they decided or they did. It's something that I'm not working directly with, but it's a very important project that we wanted to bring about. That's why probably I don't have the exact answer for all the questions. But what I can say is that it's a very active project, and they are every week taking decisions and making changes to the project. Yeah. Another question?
Well, Vicente, thank you for coming.
Sure.
Appreciate you talking.
Thank you.